Section 1. Introduction to Spring Boot. Spring Boot is a robust framework designed to streamline the development of Java applications. It builds on the strengths of the Spring framework, enhancing its capabilities and providing a faster, more efficient development process. This introduction aims to unpack the fundamental aspects of Spring Boot, setting the stage for a deeper understanding of its impact and utility in the Java ecosystem. For developers looking to quickly start new projects without the hassle of extensive configuration, Spring Boot offers a compelling solution. At its core, Spring Boot is about simplicity and speed. It eliminates the need for traditional boilerplate code, which is often a tedious and error-prone aspect of Java development. By focusing on convention over configuration, Spring Boot reduces the cognitive load on developers, allowing them to focus more on the business logic of their applications rather than the intricacies of configuration. This shift not only speeds up the development process, but also enhances the overall quality of the code. Spring Boot achieves this by embedding servers such as Tomcat, Jetty, or Undertow directly within the application, thereby removing the need for external server configuration. This embedded server approach simplifies the deployment process and enhances the portability of applications. Developers can create standalone applications that can be run out of the box, which is ideal for microservices architectures where services are frequently deployed across various environments. The framework also offers a vast array of features designed to work well together or independently. These include comprehensive support for data access, security, and messaging, among others. Spring Boot automatically configures these components when it detects them on the class path, making it easier for developers to add new features to their applications as needed. This modular approach not only makes Spring Boot versatile, but also highly adaptable to different project requirements. Section 2. The power of convention over configuration. The convention over configuration paradigm is central to the philosophy of Spring Boot. This approach prioritizes sensible defaults over extensive manual configuration, streamlining the development process significantly. By presetting configurations that meet common needs, Spring Boot allows developers to commence coding immediately, reducing setup time and potential for configuration errors. This section explores how this foundational principle influences the development workflow and contributes to a smoother, more intuitive coding experience. For instance, when adding a data source to a Spring Boot application, the framework can automatically set up connection pools and manage database URLs and credentials based on a few simple properties. This auto-configuration is made possible by Spring Boot's intelligent parsing of the application context and the environment it's running in. As a result, developers can integrate a new database or switch between different data sources with minimal effort, focusing on data manipulation rather than connection details. Moreover, this approach extends to other areas of application development such as security and messaging. Spring Boot provides pre-built configurations for most common security scenarios, which can be further customized if necessary. For messaging, it offers integration with popular platforms like Kafka and RabbitMQ with minimal fuss. This not only saves valuable development time, but also ensures that applications are robust and secure from the start. The beauty of convention over configuration lies in its flexibility. While Spring Boot provides sensible defaults, it also offers extensive options for customization. Developers can override the default settings when specific requirements dictate a different approach, ensuring that the framework remains flexible enough to cater to a wide range of development needs. This balance between default configurations and customizable options makes Spring Boot particularly attractive for both novice and experienced developers alike. Section 3. Real-world applications of Spring Boot. Spring Boot is not just a theoretical framework. It has been successfully implemented in numerous real-world applications across various industries. From e-commerce platforms to social media sites, developers leverage Spring Boot to create highly efficient, scalable, and maintainable applications. This section provides a glimpse into how different organizations utilize Spring Boot to enhance their operational efficiency and deliver superior digital experiences. One notable example is a major online retailer that implemented Spring Boot to handle their high-traffic and data-intensive operations. By utilizing Spring Boot's microservices architecture, the company was able to decompose their monolithic application into smaller, more manageable components. This not only improved the modularity of their system, but also enhanced the scalability, as each service could be scaled independently based on demand. In the financial sector, a leading bank used Spring Boot to modernize their legacy systems, introducing more agile and resilient services. The use of Spring Boot facilitated a smoother transition from older technologies to modern Java-based applications, which are easier to maintain and upgrade. The bank benefited from reduced downtime and a more robust security posture, critical for maintaining customer trust and regulatory compliance. Educational institutions have also adopted Spring Boot for their administrative and learning management systems. By leveraging Spring Boot's ability to integrate seamlessly with a variety of database systems and third-party libraries, schools and universities have developed more interactive and user-friendly platforms. These platforms support a wide range of educational activities, from online course management to student data analytics, demonstrating the versatility of Spring Boot in handling diverse requirements. In the healthcare sector, Spring Boot has been instrumental in developing applications that manage patient records and support telemedicine services. Its secure, robust framework ensures that sensitive data is protected while providing healthcare professionals with reliable tools to enhance patient care. This has been particularly valuable in expanding access to medical services in remote areas, showcasing Spring Boot's role in driving technological advancement in critical sectors. Section 4. Advantages and Future Trends. Spring Boot stands out as a leader among Java frameworks for several compelling reasons. Its ability to simplify the development process while ensuring high performance and robust security makes it a preferred choice for many developers. As we look ahead, the future of Spring Boot seems promising, with continuous improvements and expansions in its capabilities projected. This final section highlights the primary advantages of using Spring Boot and speculates on its evolutionary trajectory in the Java landscape. The primary advantage of using Spring Boot is its efficiency. By reducing the amount of code developers need to write and automating configuration tasks, Spring Boot significantly cuts development time and effort. This efficiency does not come at the expense of functionality or scalability, making it an excellent choice for enterprises that need to deploy applications quickly without compromising on quality or performance. Another significant advantage is the vibrant community and the comprehensive ecosystem surrounding Spring Boot. With extensive documentation, a plethora of community-contributed guides, and an active online community, developers have access to a wealth of resources that can help solve almost any problem. This community support is instrumental in keeping Spring Boot at the cutting edge of technology trends and best practices. Looking to the future, Spring Boot is expected to continue integrating with emerging technologies such as cloud computing, machine learning, and reactive programming. These integrations will likely enhance its capabilities, making it an even more powerful tool for modern application development. Moreover, as microservices architectures become more prevalent, Spring Boot's design, which naturally supports this architecture, will likely become even more relevant. In conclusion, Spring Boot represents a significant advancement in Java application development, combining ease of use with powerful features. Its continued evolution, driven by community involvement and technological integration, suggests that it will remain at the forefront of the Java development scene, shaping how applications are built and deployed in the years to come.